Hello, AP Chemists. So today we are going to learn how to balance redox reactions. And so the cool thing about redox reactions is there is a very systematic way to balance a reaction. And the other thing that we have to remember when we balance a redox reaction is that we have to balance not only the atoms, but also the charges that we're going to see. So we have to be able to balance atoms and charges when we balance redox reactions. Now, the thing to remember is that most redox reactions are going to take place in solution. So at least one of the components is going to be in solution. Another thing to remember is a lot of times when these things are taking place in solution, in order to get them to work and to work well, we have to either have them in an acidic environment or a basic environment. So it's really important to make sure that we look to see what environment we're in. Today we're going to start with an acidic environment. Tomorrow we'll add in the basic environment. So there are also these, again, like I said, there's a systematic way. And so what you can see here are 8 steps, 1 through 8, and these are the kind of the quote unquote rules for balancing these redox reactions. Okay, and so we're going to go through these step by step, rule by rule, so you guys get an idea of how to do this. And so here we have our balanced reaction. And so you can see here that it's not balanced, it's a very just kind of showing you what things are undergoing oxidation and what things are undergoing reduction. It's a very simple basic formula. And it looks like our hydrogens have disappeared, but we'll talk about how we can put those back in. Okay, so the first thing that we're going to do is we have to break them up into our 2-half reactions, our two either reduction or oxidation reaction, okay? And to do that, what we're going to do is we're going to kind of look at this, and kind of similar things are going to go together. So we look, and here we have one that has CR and the other one has CR. So those two things are going to have to go together because we can't destroy the CR, which means the other two things, in this case, our hydrogen peroxide and our oxygen gas, are going to go together. And so when we do this, all we're going to do is write these things down into half reactions. So we're going to say our CR2O7 2 minus is going to go to CR3 plus, and we're going to give ourselves some space. And here we're going to say, okay, we have our H2O2, and that is going to go to O2. And so what I'm going to do first is just do the top one first, and then I'll come back and do the second one. So again, so now that we have our 2-half reactions, we don't care right now whether they're oxidation or reduction. We're going to figure that out here in a second. So the first one is now once we have each half reaction, we need to balance all the atoms other than hydrogen and oxygen. And so in this case here, we see that our chromium, we have 2 here, and our chromium, we only have 1. And so to do that, well, then obviously we need to put a 2 there. That makes sense. Okay, now, perfect. Well, the second step says balance the oxygen atoms by adding water molecules. So again, remember, most of the time these are going to be taking place in an aqueous environment. And what's in an aqueous environment? Well, we have water. So we can use that water to help us balance this equation. And so now we see that over here we have 7 oxygens on the left-hand side. So we need to put our 7 oxygens over here, but we're going to do that by adding it in the form of water. So we're going to add 7 H2Os because now we have that. And so now, ooh, sweet. Okay, well, then we come back and we see step number 4 is going to be balance the hydrogen atoms by adding H+. Again, remember, we said that this is going to be in an acidic environment. And so what makes something acidic is H+. And so now we can go back and we can add those H+. So here we see that we have, because of the water, we have 14 H's on our right side. So here we would have to add 14 H pluses over here. So there we have that. Now, the last step in here is we need to balance the charge by adding electrons. And this can get kind of confusing. So we have to balance the overall charges for things. And so I'll switch colors here. And right here, we can see that we had 14 H pluses. So that means that we have 14 positive charges, right? So we have a plus 14 over here. And this right here, we have 1 minus 2 because we only have one of those. So then we have a minus 2 over here. So on this side, we have a total of a plus 12, right? Now over here, we have 2 times a plus 3. And so 2 times a plus 3 is we have a plus 6 on this side. And we can say, okay, well, we know that plus 12 does not equal plus 6, so we have to do that. So we have to get these things to equal one another. Well, the only way that we can do that is by adding negative charges because we're adding electrons. So we have to add negative charges to one side. And hopefully that makes sense that we need the plus 12 to get smaller. So over here, then we are going to have to add 6 electrons. Because if we add 6 electrons, now we're going to add a negative 6 to this, right? And so now we have a plus 14, a minus 2, and now a minus 6. And that's going to give us our plus 6. And that plus 6 now equals to plus 6 on this side. So in that terms, now we have our charges and our atoms balanced. Hopefully that makes sense. Now, so down here again, right, we don't have any atoms other than hydrogen and oxygen. Our oxygens are balanced, so now we're going to balance our H pluses. So we have to balance our H pluses by adding 2 H pluses. And now we have to balance our charge. And again, charge-wise, over here we have 0. Over here we have a plus 2. And so hopefully it makes sense that we're going to have to add 2 electrons to this side, right? So now we would get a minus 2 here. So now we look, okay? And so now we have balanced our half reactions. Now, we should see that number 1, remember the top one, we would see that, our electrons are in our reactants, right? So our top one would be our reduction. And here, our electrons are our products, so this is going to be our oxidation. And that's important when you balance these half reactions. You can't have 2 of the same. So if the electrons have to be on opposite sides. So if one is on the reactant side, then the other one, it has to be on the product side. And if they're not, then you've done something wrong. Make sure you go back and check. So right now we are through step 5. Now we have to get through the rest of the steps. And so now, because we want to get the overall reaction. So let's get the overall reaction here. Okay, and so now to do that, what we have to do is if necessary, multiply one or both half reactions by an integer to equalize the number of electrons transferred in the 2 half reactions. So we want the number of electrons to always be equal. And so if we look at that, that means that we're going to have to take this reaction right here. There's 6 here, there's only 2 there. So we're going to have to multiply this one by 3, right? And so now we're going to multiply that by 3. And when we multiply that by 3, we get 3H2O2 going to 3O2 plus 6H pluses plus 6 electrons. Okay, so we had to multiply everything through by 2, but now we see the electrons are the same. So now if we're looking to get the overall, so now add the half reactions together, canceling out like species that are on the opposite side of the arrows to get the overall net ionic equation. So what I'm going to do is just write this one back down over here. So we have 6 electrons plus 14 H pluses plus Cr2O72 minus going to 2Cr3 plus 7 H2Os, right? And again, we're going to add these up. Hopefully the first thing that you notice is that the electrons can cancel because there's 6. You should never see electrons in the overall. They should always go away, right? And then the next thing that I see that we can take out are the H pluses. Here I have 6 and then 14, so I can get rid of that, and that would leave me, because 14 minus 6 is 8, I would have 8 H pluses. And I think that's the only thing that I can cancel out. So now if I'm writing the balanced overall, I would have 8 H pluses plus 3 H2O2 plus Cr2O72 minus going to 3O2 plus 2Cr3 plus 7H2O. And so that looks a lot different than what we started with. But again, if I look at this, everything should balance out. I have 8 plus 6 hydrogens. So that's 14 hydrogens, 14 hydrogens. I have 6 oxygens plus 7 more, so that's 13. I have 6 plus 7, that's 13. 2 CRs, 2 CRs. Over here I have a grand whopping total of a plus 6 charge, and here I have a plus 6 charge. So charges and atoms should balance after we do this process. If you follow those steps and do this and work at it, you can get really fast at balancing these reactions because these steps really help do it. It's really systematic that way. Okay, go ahead and practice balancing those equations from the book problems. And if you have any questions, make sure you reach out. All right, guys. Peace, love, happiness. Thanks for playing.